So, good afternoon, dear participant of this online course on natural resource management. Today, we have a session on concepts and demonstration of online geodata repositories and application of natural resource management. So, in this particular session, I will try to brief you about different source of data which is available in online data repositories or in any geoportal. I will also try to explain you the possible application of these data sets for the natural resource management, including disaster management. So I have compiled the list of data repositories, and I hope in future, if sometime you are taking any project or any studies on any specific areas, so you can explore these sources for data availability. So the majority of data sources what I will be discussing today are available in open source domain, or sometimes we also call it as a freeware product. So during this session, I will switch off my video and I will be focusing main on the screens so that you'll get the better visibility at your end. So my name is Harish Karnatak. I'm heading a department called Geo Services IT and Distance Learning Program. So I'm taking care of these distance learning programs. In background, we are developing the different platforms. We are developing different techniques for the online learning. And I hope you must be enjoying this learning through e-class platforms and also the content that our colleagues are presenting during the sessions. So we strongly believe that definitely these contents will be useful for your career growth or your knowledge enhancement. So today, the session, before starting the sessions, we have to understand the different data access mechanism through web portals or geoportals. You know that in a traditional method of data access, what we do, we use the physical data transfer, or sometimes in online terminology, we call it as a physical data download. That means so whatever format, that is the original format of data is available, same data you are downloading into your local computer, and then you are using that data for your own study. So traditional data access is something like this. But here, what we are doing, we are physically transferring the data from one place to another place. If this online system is not available, then what will happen? You will be using your CD, your hard disk, or some other secondary storage devices to transfer this data from the host organization to your local system. But the internet platform is allowing you to use this communication system to transfer the data from one place to another place. But still here, there are certain limitations. So one thing is, it has advantage like the data is almost available in near real-time mode. Sometimes real-time data also you can access it. But there are certain issues like if you are not having the proper bandwidth, definitely data download will be difficult. But in the same time, although you have a very good bandwidth, which is already available these days in the cities and the major towns in the country, but what is happening, suppose the host organization is having a huge amount of data repository like 10 terabyte, 20 terabyte, 30 terabyte, or maybe sometimes 100 or sometimes a petabyte of data, then physical transfer of this data from these servers to client still will be challenged. For example, today in ISRO geoportal called Bhuvan, we are hosting around 30 terabyte of data into our servers. If I give you the full access of downloading this data into a local computer, but still you will not able to download this 30 TB data into your local computer, because one way is your bandwidth, or sometimes the bandwidth is okay, fine, you have the sufficient bandwidth, but at the same time, your local storage capability of your computers, like your laptop or your desktop, will not support you to store that much data physically or locally into your system. So this is one thing. Second thing is, if suppose you are downloading some data from these online data repositories, but after some time, maybe after 5 minutes, 10 minutes, 1 hour, or 1 day, or 10 days, or maybe after 1 month, the host organization is updating this data, but you are not aware of it. The data is updated. So this physical data transfer is a traditional method, but in today's environment, slowly this kind of data download systems are phasing out, and now we are using the advanced technologies which are allowing us to access the data through web services or APIs. You will be knowing about it. So web services is one typical data structures through which you can get live data, but here the storing this data into local computers are not required. And in APIs also, you know that today the data providers like Google Maps or Google Earth Engines, they have the terabyte or petabyte of data in their servers. But what they are doing, they are giving you access through APIs. These are the application programming interface. If you follow their SOPs, their guidelines, so without physical download of this data, you will still will have you access to this data, and you can use this data for your own applications or own project. So today the web services APIs concepts are becoming very popular among the data providers as well as the data users. So this concept is very important. So you have to understand this method of data access so that without physical download this data, you can access it. The web services are hosted in the central or distributed data servers. So that means based on the load on the servers, based on the policies, copyright issues, the host organizations are deciding either they need to store or they need to publish this data as a central system or distributed system. So here, when I say the distributed, means the data is basically divided in multiple servers, and these servers are sometimes located in the same place or sometimes maybe located in the different physical location as well. And another important technology which is becoming very, very popular these days is called cloud-based computation architectures, or sometimes we call it as a cloud computation architecture. And in these architectures, the data is hosted in the cloud, and the cloud is a very interesting mode of computation infrastructure management, where we have the excellent scalability options. So in the centrally, the data storage is available, and the cloud is hosting these data sets, or sometimes the APIs or these web services for the client. The computation cloud provides a platform to serve not only data as a service, but also infrastructure, software, platforms, all these things as a service. When I say the service, that means there will be some the protocol, or there will be some method to access the services, and if you are following it, you can access not only the data but also their software, their platform, their infrastructure. So that means you can hire it and you can make your own business model. The slowly these data centers are moving toward the cloud computation in architectures, where there are certain advantages for the host organization and user as well. So that's right now you have to understand that these web services, APIs are basically hosted in the cloud computation infrastructure. And if you talk about the GIS, similarly here in geographic information system, servers are also emerging, and these GIS servers are very powerful servers, and they are not only hosting the data, but also they are providing various utilities or software tools to their users, like you can do the mapping, and that is your online mapping. You can do the visualization of data in 2D and 3D format, and you can also publish your data as a data service. It's a very interesting model. Here, once you publish this data as a data service, then your users can directly access this data without physical download into their computers. So they can access this data service directly into their scientific models, their studies, and they can start consuming these data sets for their own local purpose. These servers are also allowing us to do the editing of the data, not only data creation, but also in the data stage, data can be edited here. So here multiple versions can be maintained into the servers, and at the same time, these GIS servers are also allowing us to do the geoprocessing activities, that is called geoprocessing services. So again, it's a very interesting model of computations where the softwares are not available as a package or not available as an exe file, something like this. Here the softwares are available as a service. That means I can call the service, I can provide input to the service, and the service will process my requests in the cloud or in the servers, and only I'll be getting the output. So here, the typical requirement of computation like processing capabilities, the secondary storage, as well as the RAM or memory requirements, everything you can match by using cloud computation architectures, and your processing will be happening in the server infrastructures, and only you'll be getting the output. And same time, these CR servers are also having capability to publish as a catalog service. So catalog is something like a clearinghouse or gateway through which you can search different type of data, and it will redirect you to the respective servers. These are the few capabilities which are available in the GIS servers, and typically these GIS servers are a set of hardware and software. So here, hardware means it is server hardware, of course, but on top of the server hardwares, we'll be installing the GIS server applications so that we can satisfy the requests of our clients through the client server computation architecture. So here, when we have the GIS server in place, in our last modules, in the geocomputation modules, we discuss about WebGIS, GIS web service specification and all. But here, just I am quickly briefing you, especially for the participants, those are only joining this particular course. Here, the GIS servers are a set of software products, and these softwares are basically connecting to the database servers and web servers, and sometimes they are acting as application servers and providing services to the users. In background, we can store two types of data. In general, one is called structured data, generally which we store into a relational database management system, or sometimes we call it a geo-relational database management system. And today, most of the relational database management system, or RDBMS, are providing us the capability to store our vector and raster data inside the RDBMS, so that we can use the structured query language or SQL to perform different spatial analysis on top of this data. But another important aspect which is emerging these days is called unstructured data, or sometimes it's big data. So for this purpose also, the different data providers or database systems, like we have the Edge-based, we have the Hadoop framework, they are also capable to handle the unstructured data, and the GIS servers are very much compatible with this product like Edge-based and Hadoop. And finally, when we are presenting output to the users, and these outputs are basically served as a XML, we call it the extensive markup language. And these XMLs are very important, and these XMLs basically provide direct interoperability to the users, so that they can directly access the data, and they can use this data in their own software application the way they want. So here, the role of XML is becoming very important. They provide the complete interoperability to the users, so that the data is available in open platforms, and users can use this data as per their own local project requirement. So here, the role of one organization called Open Geosocial Consortium, or OGC, is very important. And this organization is a non-profit organization. It's basically providing the geospatial data standards for data sharing in the internet platforms. And their vision is basically to develop the standard for geospatial web services. So this term I used earlier also, this web service is not website, you have to understand. Basically here, the idea is to share the data in an interoperable environment, so that the users can use this data the way they want. And the OGC is working on a mission called A World in Which Everyone Benefits from Geographic Information and Services Made Available Across Any Network, Application, or Platforms. So here you can see that the any network, application or platform. So here the connectivity through the networks, any software applications at the user end or as well as the server side. So it is basically called as a interoperable application. So interoperable application or interoperable data. So what does it mean? So this was a very big issue 20 years back. If you go to the history of GIS, that time people used to create data into the proprietary using the proprietary softwares, and these software used to give the output as a proprietary format, and these proprietary formats were restricting to users to use a specific software. For example, if you are using these days like a ArcInfo, so ArcInfo files are restricted to ArcInfo. IIRS files are restricted to IIRS. Similarly, other software products files are restricted to their product itself. But here interoperability means like today you are getting GML, you are getting SIF file, you are getting TIFF file, and after these formats, now data is becoming open. So that once you have the SIF file, you can open the SIF file in any GIS software like Quantum GIS, in ArcGIS, IIRS, anywhere. So similarly, for all kind of data, the OGC is working since last 20 years on this mission that data should be interoperable. It is not only about the data format, they also talk about the data network, application and platforms. So today if you see what they have done, they have published more than 50 such standards for different type of data, including the sensor data, or sometimes called the sensor web enablement, SWE. And here they have standard for raster data, they have standard for vector data, they have standard for the catalog services, they have standard for transformation services, they have standard for processing services. Around 5 to 6 categories are there, we will be discussing in coming slide. But ultimate objective is to achieve the interoperability in data set. So these are the typical architectures and of the OGC. You can see 3 major terminologies like a find, bind, and publish. If somebody is coming from the computer science background, they can understand that this is the same architectures what we study in terms of service-oriented architecture, or we call it the SO architecture. So here, the catalog is basically for searching the data, or sometimes we call it finding out the data. And then bind means it's basically establishing the connectivity between the users and the user and service data providers, and publishing is the responsibility of data provider here. So typically, if you see the OGC specifications, there, as I told you, more than 50 such standards are published by OGC. Typically, if you categorize these standards, you can categorize in 5 to 6 categories. One is called catalog, second is called processing services, third is called encoding services, fourth is called data services, and fifth is called code trial services. And in 6th category, you can keep the other services as well. So catalog services, they have standard like CS code, CSW, EBREM, they have the CSW 19115. And similarly, for processing services, they have like a sensor planning services, web processing services, coordinate transformation services, and so on. For encoding, which is very important, especially for GIS users. For example, suppose you want to display your legend on the map, then you require some standard to define the legend. So for this purpose, we have this style layer descriptor, or we call it SLD. Similarly, for sensor model language, we have the standard. For the JPEG 2000s, KML, you know that this is a standard designed by Google, but today it is a standard, an open standard accepted by OGC, called the keyhole markup language for the 3D visualization in Earth Engine environment. Similarly, for data services, they have the standard like simple feature services for the vector data, for web coverage services, for raster data, WCS transition services, sensor observation services, table join services, web feature services. These are the example of data services. What does it mean? So data services means if data is published in this service specifications, so anybody can access this data or through a URL as a original data. What does it mean? They will be giving you a URL, and if you include this URL into your GIS package, then it can act as original data, and you can perform different type of vector and raster data analysis on top of this data layer. So here you will be not downloading this data physically into local computers. In real-time mode, data will be accessed from the server, process, and only the output will be stored in the local computers. Similarly, they have the specification for the visualization purpose like web map services and web map tile services. These are the typical standards for the geo visualization in 2D and 3D environment. So for this purpose, you can understand that the all aspects of geographic information system or the geographic information science, OGC is having the service standards. Now, this is background or technical background about the data publishing, about the data sharing. Now come to the popular online geodata repositories. Basically, these are the websites or web portals. Those are following these standards or guidelines and publishing the data to the users. So I'll be taking first few popular geoportals and their capability we'll be discussing. In the second phase, I'll be listing out some of the popular online data repositories from where you can either download the data as a physical data or access data as a web service or API. Now come to the popular geoportals. The first, of course, name is coming as a Google Maps. I hope most of the learners or the students of this course must be using Google Map in some form in their life. And you know that Google is providing various location-based services to the users, and their strength is, or specialty is, to provide the global satellite images and the map, that is a 2D and 3D maps. And at a street level, this information is available to the users. So this is their strength. The similar geoportal is called Bing Map from Microsoft. This is the URL, and they are providing global satellite images and maps basically on the roads and point of interest. OpenStreet is another very interesting website developed by a society from UK. A gentleman called Steve Coase. He has started this project sometime in 2004, and he talked about typical data democracy. Here, the geospatial data by the public for the public. So here, open and free vector data is available, which is created by using the concept of collaborative mapping. So what you can do, you can visit this website and you can create your login. So it will allow you to do the mapping in any part of the world. At the same time, you can download your data as a zip file or as a KML file. Same time, you can also download the data of others, basically in the form of vector format. So this is an interesting website of geoportals. If time permits, I will try to showcase you how you can get access of this data. They also provide the cloud, OpenStreet Cloud, where the ready-to-use shape files are available for entire globe. You can download this data in the vector format. Scale will be around 1:10,000 scale. So it's freely available. Wikimedia is not a GIS platform, but it is a very interesting crowdsourcing approach for tagging the ground information. They also provide a lot of utilities to the users so that you can directly log into the system and you can tag different geographical features. And they are creating the huge data repositories by using the concept of crowdsourcing. ISRO Bhuvan has made a place here in this list because this is one of the very, very popular website or data repository for the vector raster data from India. It provides the rich contents and seamless availability of multi-temporal, multi-resolution satellite data for entire Indian regions. And they also provide thematic and disaster-specific services to the users. It's a very interesting website. If time permits, today we'll spend some time on this URL as well. So what you can get, this data is basically captured or created by ISRO, and it's available for the public for free of cost. You can download this data, or you can also consume web services hosted by ISRO through this portal. And they have a different OGC web service specification like WMS, WCS, WFS. All these service specifications are published, and you can get access to your data. And I can tell you around 30 terabyte of data we are hosting here. Not only the satellite imageries, but also the maps which are created by using the satellite images. Although we are not a mapping agency, ISRO is a space agency, but what they do, they provide you the satellite image plus the satellite image driven maps for your own project or R&D purpose. Sometimes you can also use these map product for operational purpose. Another interesting website in India is called Map My India. Recently, they have collaboration now with ISRO as well. Now the Map My India maps are integrated with ISRO Bhuvan satellite imageries and are available as a open service to the users. Although they are not an open company, they are a commercial company. They provide the rich point of interest or POI data, detailed maps of India. And we have seen last 2 years or 2-3 years, they are very active in updation of these maps by using satellite imageries, by using ground survey, by using some other techniques. And I strongly recommend users to explore this website to get the good quality maps of India. Indian NSDI, that is the Indian National Spatial Data Infrastructure, is another initiative by Department of Space and Departments of Science and Technology, or DST in India. So they are not providing maps or data as such, but they provide the metadata, catalog, and policy document related to this data. So in India, all the mapping agencies or spatial data providers like Survey of India, Forest Survey of India, Geological Survey of India, ISRO or Department of Space as such, or other surveying agencies, they provide the complete metadata, that is a data about the data. So you can search for appropriate data, where it is available, what format is available, either it's a free or commercial basis. All these details are published under this website. Biodiversity Information System is a website published by IIRS itself. We provide here the biodiversity special viewers and data download utility. This data content of plant biodiversity of India. This is the project specific website. Although the project is complete, but still the site is available to the users. So what we provide in the output of this project. The project name is biodiversity characterization at landscape level using remote sensing and GIS. This project was one of the very ambitious program of ISRO or Department of Space in collaboration with Department of Biotechnology. And we have generated huge amount of data on the natural resources of India, especially the bioresource of India. And these maps are freely available in this website, plus the ground sample points or data of around 16,000 sample plot is available through this website. Indian Bioresource Information Network is another very, very interesting project which is being executed by ISRO, again in collaboration with Department of Biotechnology and other bioresource data provider in the country. What we are trying to do here, we are trying to establish a special data infrastructure for bioresource of India. So here not only the plant data, but the flora and fauna, both data, animal data is also available in this website. And all the data sets are geotagged, and you can get information about which species is available in which locations, their special distributions and all. So very interesting website. Like, so for example, if you are looking for the different type of medicinal plants in India, their locations, their specialty, their uses, all these contents you can get through this website. India Water Resource Information System is again an interesting initiative by Central Water Commission, CWC, and Department of Space. We developed a very rich data contents for ground and surface water of India. So last 100-year data is hosted in this website. Initially, this website was hosted in ISRO domain, but now it is transferred to CWC, and they are hosting this website under indiawris.gov.in. Very interesting website related to ground and surface water of India. Some historical data sets are also available, and they have around more than 30 sub-information systems related to water source of India. Bharat Map is another interesting initiative by MITI, this Ministry of Electronic and Information Technology. What they are trying to do under NIC, they are trying to link the demographic data of India, like census data or other geotag informations, in the form of the maps, and detailed maps slowly they are upgrading these data repositories and is available in open domain to the users. In addition to that, we have many such online data repositories or geodata repositories for satellite imagery and thematic maps. And if you search in the Google or any search engine in internet, you'll be getting hundreds or thousands of such websites. But for your benefit, what I did here, I just compiled the important data repositories so that directly you can refer in futures. If you are really interested in this domain of remote sensing and GIS, so to explore or to understand further, definitely you require the data. And these data sets are available in online data repositories, which I'm going to discuss now. So first, the name I will take here, the USGS Earth Explorer. This is a very interesting website developed by the United States Geological Surveying Organization. So what they provide, they offer the latest satellite views like Landsat, SPY, satellite like Corona missions, hyperspectral data from the Hyperion mission of NASA, and they have compiled the data from other space agencies as well in a single online platforms. You can search for this data, and last 40-year data of the Landsat mission is available in the open domain. You can download this data physically, you can access this data for your own project, and they provide the complete global coverage of this data. It's not restricted to any specific region. Then the next name I will take here, the Sentinel Open Access Hub. It's another important website by European Space Agency called ESA. They provide the Sentinel-2 high-resolution latest satellite imagery of the world, and Sentinel-2 10-meter resolution in red, green, blue, and near-infrared spectrum is available. And this is one of the most popular websites for the high-resolution satellite imageries. Every 10 days, they provide the new coverage or new data set of the same areas. It's around 12 spectral bands, range from the coastal to SWIR band, and they have the Sentinel-1 C-band SAR data as well. So here, not only the optical data, you can also download the C-band SAR data from this website. And the URL of this website is this. Of course, they provide the global coverage. So very, very popular website. If you are looking for 10-meter spatial resolution satellite imagery, every 10 days or 15 days, what are the changes happening in the ground, you can visit this website. NASA Earth Data Search. This is another data repositories, online data repository from NASA. They provide Earth and science data discovery systems, derived data from the biosphere, cryosphere, hydrosphere, or atmosphere. Most products come from a data and application center called DAC. And they provide the land cover data, an excellent source of global land use and land cover data. It has the specialized satellite-derived data like permafrost and wetland types. So these are some scientific data products what you can download from the NASA data search, and this is the URL of this particular data repository. NOAA Data Access Viewer is a source of authentic database along the coast. If you are a researcher or a student of the coastal studies, so you can look for this data, and NOAA Data Access Viewer holds satellite, aerial, and LIDAR imagery. So if sometime you require the LIDAR imagery for the studies, you can look for this particular data repositories. The URL is this one. Now, Digital Globe Open Data Program, although this is not an open data repositories, but they are the commercial data providers in the world. What they do, they provide some sample data to the student, especially for their own study purpose. Sometimes if you require a very high resolution data, something like the world view data for your studies, and you want to understand how this data looks like and how you can use the data for understanding your different geospatial processing techniques in the GIS. So what they provide under this open data program for any natural disasters, Digital Globe provides satellite imagery for relief in open domain under the Creative Commons License 4.0. They provide the sample data. If you want to simply experiment, try downloading from their sample imageries. For example, it has building footprints, elevation, stereo, and true color imageries. So natural color imageries you can download from their repository. But they are not providing open data as such for the complete globe. They have the limited access here. But as a student, you can explore their sample data so that you can do your own experiment with the satellite imageries to understand their band combination, to understand the data arrangements, to understand the information extraction theory, and all these things you can do here. Another commercial provider is IIRS Defense. They are providing collection of sample imageries from the satellite like Spot, Pleiades, Rapid Eye. These are some of the best in class as per the high resolution satellite imageries are concerned. Before purchasing any data, if you want to understand either the data from Pleiades or Rapid Eye is useful for your own study or not, so you can explore the IIRS Defense data product. Of course, they have the limited coverage, not for entire globe or any country specific, but sample data is available. NASA WorldView is a good for downloading raw data and providing access to a variety of scientific products. Of course, they provide the global, but it's very coarse resolution data. But I will recommend to the student to explore NASA WorldView as well. It's a good repository for the satellite imageries from this space agency. NOVA class is again from the NASA, but they focus on three important domains of the ocean studies, atmospheric studies, environment, and climate studies. So if you are from this background of student of ocean science, atmospheric science, and environmental science, so you can look for this repository. This is a comprehensive large array data stewardship system or class. They have the Coast Watch is a collection of the measurements such as wind, temperature, and color. Atmospheric imagery like a GEO is the most advanced state of the weather satellite, and product cover from the ozone to aerosol under the environment and climate study. About the ISRO Bhuvan, they have very important data repository under NRC Open EO Data Archive, or we call it as NOIDA. We provide the rich contents and seamless availability of multi-temporal, multi-resolution satellite data for entire Indian regions and thematic and disaster services under ISRO Disaster Management Support Program. This is the URL of the website, but here data for entire globe is not available. We provide only the region-specific data sets. Our focus is on India, but sometimes we provide data services to our neighboring country, SAARC country, and Asia Pacific country as well. EXA Global allows 3D World. It is a very interesting website or data repository from Japan. They provide one of the best world-class 3D data sets in 30-meter spatial resolution. They have basically a product called Digital Surface Model, and it uses the advanced land observing satellite called Daichi allows, which is a type of L-band radar. So the digital surface model, whatever is available in this website, is coming under the category of L-band radar. That is by using the microbe data, the 3D surface is generated here. Beto Vision is a website again for the spot vegetation and ETOP as a free satellite imagery. These coarse resolution satellites basically provide vegetation patterns across the Earth's surface. Similarly, we have the NOVA Digital Course, Satellite Landwear, Unaveco. These are some popular websites. I'll be sharing this PPT under study contents in the e-class LMS, so you can download. But the top 10 websites already I discussed. The remaining we can leave here, and you can refer in for your future studies. Now, these are the popular source of satellite imageries. I have not discussed much about thematic, but except few popular science missions or science data repositories. But let us see the OpenGIS data sources here in the coming slide. Now, these are the lists of the popular GIS data repositories from where you can get down data for either as a physical data or as a GeoWeb service or as a API. First is the ISRO Open Data Hub. They have around 250,000 plus open data sets from around 5,000 plus organizations worldwide. And you can download the format like the spreadsheet, KML, and SAFE file format. APIs are OGC, WMS, GeoJSON, and GeoServices. And this is the URL of this website. Although ISRO is a company provide the software solution for the GIS, their product ArcGIS is one of the most popular product in GIS community. But recently, they also opened the ISRO Cloud for the student community, for the researcher community, and sometimes I can say very useful for the professor also. So this is a very interesting data hub as per the data, open data is concerned in this particular domain of GIS. Natural Earth data supported by North American Cartographic Information Society, cultural, physical, and raster data sets, quick start kits, MXG and QGIS files are also available. If you are doing some experiment during this course, you may be knowing that the MXG and QGIS, they have these are the formats supported by RGS and content GIS, QGIS files with all essential style layers. So ready to use map styles are also available to the users. Not only data, they provide the complete the packaging as a GIS format so that you can understand this data better way. OpenStreetMap already I discussed about it. Detailed free GIS data, different level of accuracy and completeness, and high spatial resolution cultural vector data such as buildings, road, waterways are available in this website. Here you have to make a note. There are two URLs. One is openstreetmap.org. You can do the mapping activity. You can download as a GML or KML file. But sometimes we have seen that the students are very much interested to download data as a state file. For this purpose, you can visit this website called downloadgeofabric.de. This website provides a cloud of OpenStreetMap. Through this website, you can download the zip file of the original data hosted in the OpenStreetMap. NASA Socioeconomic Data and Application Center, we call it CDAC. It shows the human interactions with the environment. It has a wide variety of coarse global free GIS data, flagship data, is its graded population of the world, and global socio-economic data comes from 15 different themes, and socio-economic data includes a range of topics such as agriculture, climate, and health, and so on. And this is the URL of this website. Food and Agriculture, this organization FAO, they have a very interesting catalog or gateway system called GeoNetwork. And this is one of this one is the FAO GeoNetwork, which is another portal of free GIS data from United Nations. So UN also is creating a lot of data related to socioeconomic, especially they call it socioeconomic data, especially for development purpose. And they have the global agriculture, food security, and fisheries are some of its key free data sets. You can download this data, or sometime they are also providing this data as an API or as a web service, so that directly you can consume these web services into your own programs, and the real-time data can be integrated into your own projects. Open Topography is a repository which provides support to high spatial resolution topographic data and tools. In particular, it houses LIDAR data, which is a unique feature of this website. And LIDAR data, 90% in United States, Canada, Australia, Brazil, Haiti, Mexico, and this country, Puerto Rico. So what they provide, these are the only a sample data. As a student, suppose you want to understand how this LIDAR data looks like, because LIDAR-based surveys are considered as one of the most costly affair in the GIS domain. So in general, the data is not available to the students. So many times students ask us, suppose I want to experiment with the LIDAR data, how to do it? Because data is not available. So I searched in internet, and then I found that the Open Topography is a very interesting URL through which you can get the sample data, LIDAR data. Although right now the Indian region data is not available, but as a student doesn't matter. You can have this data for your own learning purpose. UNEP Environmental Data Explorer is a United Nations Environment Programs, is an authoritative source of UN data. It holds more than 500 variables such as freshwater, climate, and health. And themes include population, forest, emission, disasters, GDP for spatial and non-spatial data. This is the URL. And of course, they have the global coverage. NASA Earth Observation, NEO, is like a real-time climate snapshot of the world. NEO focuses on the 5 themes, which are 50 plus global data sets, mostly climate related, and constant update ensuring timely climate information of our globe. They are continuously updating, and that's why it's called the near real-time climate snapshot of the world. And it's accessible in a variety of GIS format, and all raster grids are atmospheric, energy, land, light, ocean GIS. Terra Populus, it integrates census data from over 160 countries around the world. It spans up to 6 decades for household level and aggregate data for more than 80 countries. Micro and environmental data describing land cover, land use, and climate. This is the specialty of this website. ISRO Bhuvan already I discussed, but when you talk about the thematic data, earlier I discussed with respect to satellite imagery, but now I am discussing in respect to thematic data. Here we have a program called Natural Resource Census Program, or we call it the NR Census Program. In general, we update the different themes of natural resources. We have identified around 7 themes every 5 years, and some your geological themes every 15 years, like geomorphology lineament, every 15 years we update, and land use, land cover, land degradation, vegetation type, watershed, wasteland map, all these things we update every 5 years by using the satellite imagery. So it has the regional coverage, but a rich data repository is available in the ISRO thematic services as well. These are some examples how you can get access to this data. For example, this is Earth Explorer from the USGS. You know that you can search data here by your criteria, data set, additional criteria. You can also draw a in point of interest, like I'm interested on this region, show me what data is available. It will list out all the data products and their coordination, acquisition date as well. So different time period data is available, and these are the different type of data. Right, I told you initially they have the good repository of landscape data, but they also integrate data from other space agencies also, and these are you can pick from here. Otherwise, a simple data search engine is available, and you can create your login there, and then you can physically download this data into your local computers. ISRO Bhuvan, as I told you, this is a online data repository developed by ISRO sometime in 2009, and today it's available as an open data repository to the users, and it's a completely indigenous development by India. Not only the data, but also the software product is also developed in-house within ISRO and now hosted for the public access. This is a URL of the website, bhuvan.nrsc.gov.in, and this is the URL homepage. Now recently we have updated the homepage also. I have to update this slide, but you can see the core components like Bhuvan 2D, Bhuvan 3D, Open Data Archive, Climate and Environment, Thematic Services, Disaster Services, Ocean Services, and Mapping Services. Similarly, for government or central government ministries, we have the dashboard called G-Governance Dashboard. You can see the in different flagship program of Government of India, how this technology is being used, and some of the success stories like Clean Ganga Mission, Prime Secretary Sichai Yojana, Chaman programs. We have the Postal Department, Urban Survey. We have the Manrega programs, how this geospatial technology is being used, and how the satellite imagery from this Bhuvan portal are being used for this flagship program of Government of India for the successful implementation at the ground level. If you talk about the data availability, I will not read all the content because, as I told you, it's more than 30 terabyte data. And as per the data layers are concerned, we are hosting more than 5,000 map layers here, and you can get this data through this catalog and this data repository. These are some examples here, like land use, land covers, urban land use, wasteland, geomorphology, soil erosion, salt affected areas, urban sprawl, water bodies, flood annual layers, flood hazard location layers. There are so many products which you can get. Another website by ISRO is called Vedas. This is a visualization of Earth observation data and archival system. This is a scientific website developed by our colleague in Space Application Center in Ahmedabad. It is an online geoprocessing platform using optical, microwave, thermal, and hyperspectral Earth observation data, covering applications particularly meant for the academia, research, and problem-solving environment. So we focus on the academic point of view and research point of view, and you can get data on the renewable energy, coastal and marine resources, hydrology, climate studies, cryosphere, atmospheric and social science, planetary science data set like our planetary missions like Chandrayaan 1, Chandrayaan 2, Mars orbiter missions. Suppose you are interested on this domain, you can visit this website, and here we are providing like a cloud services. You can create your login and you can do experiment with this environment, and a lot of data analytics can be performed on the fly. So it will give you the result immediately, and in fact you can download the results into your local computer for your further study. MOSTEC is another data repository, again hosted or developed by ISRO. You may be knowing about the geostatistics satellite from ISRO, like a Kalpana 1, we have the INSET 3D and INSET 3DR, or some other weather-related satellite. So all these data sets we have hosted in these data repositories, completely free, open data repositories, and you can download the data, and you can create your logins, and we provide the near real-time data and to the users. You may be knowing that the geostatistics satellites are providing the observation every 15 minutes or every 30 minutes to our data station or the station. So we are immediately updating this data to the servers and then making available to the users. Very interesting website for this kind of weather and climate data study. Data Portal of India is another interesting initiative by Government of India, where the data from the different data providers, not only the spatial or GIS data, but also data from other themes are hosted here, and you can search for this data under the Data Portal of India called data.gov.in. So rest of the slides are explanation of these portals or repositories. I'm just skipping it because time is not permitting me. Already session is about to complete now. So this is a National Climate Data Centers, NCDC, land-based stations and satellite data. Under this NCDC, we have the radar and some data products as a model outputs, weather balloon, marine and ocean data sets. And then we have the other kind of severe weather parameters and so on. You can explore this URL as well. Global inventory modeling and mapping studies. This is basically global land cover mapping facilities. And Giovanni is the name of the repository here. They provide the interactive visualization analysis for GES, DISC, DISC, and guided Earth Science Data Information Service Centers. These are some global data repository for climate change related studies. Postal is again a thematic centers, data centers associating R&D and services to describe the soil and vegetation from Earth observation satellite data at regional and global scale. We have the vegetation and soil, radiations, water, and another URL is the large web, is another repository. Ocean color web is for ocean studies. OCM data portal from ISRO as well is available. We provide the geophysical products through this portal, right now hosted in Google website also. So that's all from my side for today's session. These are the few websites what I have highlighted in this presentation. I hope this will be useful for you sometime in future for your studies. In beginning, I discussed about technical aspect, but in the later stage, I discussed about the data repositories. With this, I conclude my session here, and you are welcome to post your queries in the e-class platform so that we can have few questions for the discussion purpose. And thank you very much.